Today we are going to do the breaching a Active Directory room from Tryhackme. So this room teaches us how to get initial access on the Active Directory. Active Directory is used by 90% of the Fortune 1000 companies. If organization state uses Active Microsoft Windows, you are almost guaranteed to find a Microsoft Active Directory. So Microsoft AD is dominant suite used to manage the Windows domain network. However, since AD is used for identity, AD is used for identity and access management, it holds the key to the kingdom, making it most likely target for attackers. So before we can exploit the Active Directory for privilege escalation and lateral movement and goal execution, you need to gain initial access first. You need to acquire a valid set of credentials due to number of Active Directory services and features. The attack surface for gaining an initial set of Active Directory credentials is significant. In this room, we'll be discussing several avenues, but this is no means an exhaustive list. When looking for a first set of credentials, we don't focus on permissions associated with the account. Thus, even a low privilege account will be sufficient. We are just looking for a way to authenticate into the Active Directory and perform further enumeration on the Active Directory network. So in this network, we'll be covering several methods that can be used to breach Active Directory. This is by no means an exhaustive list, as mentioned before, and several new techniques are discovered every day. Some of the techniques that we will be covering in this video is Active Directory anti-LM authenticated service, LDAP bind credentials, authentication relay, Microsoft deployment toolkit, and configuration files. So connecting to the network, you can just visit the access page and you can just refresh the page once and generate the network VPN server open VPN configuration file and then connect to the network. So let me just quickly do that. So I have the OpenVPN file. So we can just connect to the OpenVPN. Oops, sorry. That's 3, I guess. 2. Device or resource busy. Tryhackme. Perfect. So let's try to connect to the network again. And then after that, you need to perform this. We believe we need sudo access, and we need to replace the domain controller IP address with 10.200.27.101, 10.200.27.101, I believe. Enter. can we just put this file in resolve.conf? Perfect. And let's see if we can ping the DCIP. So we are able to ping the domain controller IP address. Let's see with the URL. And we are successfully able to ping the DC URL, the fully qualified domain name. So the DNS is perfectly working. We connect it to the VPN. So I have completed the AD basics room and about ready to learn the AD bridging techniques. I have connected to the network and configured the DNS. So task 2. Two popular methods for gaining the access to the first set of AD credentials is open source intelligence and phishing. So we will be only briefly explain the two methods here, as they are already covered in depth in other rooms. That's OSINT and phishing. So OSINT is used to discover information that has been publicly disclosed. In terms of AD credentials, this can happen for several reasons. Users who ask for questions on public forum like Stack Overflow but disclose the information such as their credentials in the question, or the developers that upload scripts to the services such as GitHub with credentials hard-coded. Credentials being disclosed in past breaches, since employees use their work account and sign up for other external websites. Websites such as Have I Been Pwned, Dehashed, provide excellent source for determining if someone's information such as work email was ever being disclosed in a data breach. By using the OSINT techniques, it may be possible to recover publicly disclosed credentials. If we are lucky to find the credentials, we still need to find a way to test them whether they are valid or not, since OSINT information can be outdated. In task 3, we will be talking about anti-alarm authenticated service, which may provide an excellent avenue to test credentials to see if they are valid. Detailed room on Red Team OSINT can be found over here. So phishing is another excellent method for breaching Active Directory. Phishing usually entices users to either provide their credentials in a malicious web page or run a specific application that will install a RAT, remote access Trojan, in background. This is prevalent method since RAT would execute in user's context, immediately allowing you to impersonate that user's Active Directory account. This is why phishing is important topic for both red teams and blue teams. A detailed room about phishing can be also found over here in the Tryhackme. So I understand what is OSINT and how can it be used to breach the AD. And we also understood what is phishing and what is the most popular website that can be used to verify if your email or password that's have I been pwned. So we will be talking about anti-LM authenticated service, the anti-LM and net anti-LM. So anti-LM, new technology land manager, is a sort of security protocol used to authenticate users' identities in the Active Directory. So anti-LM can be used for authentication using a challenge-specific response based called net anti-LM. This authentication mechanism is heavily used by services on network. However, services that use net anti-LM can be also exposed to the internet. The following are some popular examples: internally hosted Exchange mail servers that expose Outlook web app over login portal, RDP service of a server being exposed to internet, or expose VPN endpoints that were integrated with Active Directory, or active web applications that are internet facing and use make of anti-LM. web applications that are internet facing and make use of NTLM. Net NTLM can also be referred as Windows authentication or just NTLM authentication, allowing the application to play the role of middleman between client and Active Directory. All authentication material is forwarded to the domain controller in form of challenge and completed successfully if the application will authenticate the user. This means application is authenticating on behalf of user and not authenticating the user directly on the application itself. This prevents the application from storing Active Directory credentials, which should be only stored on the domain controller. The process is shown in the following diagram. So the application users first request access to the server sends the challenge, and client sends the response of the challenge, and then the server sends the domain controller response on step 6. So first after step 3, the server sends the challenge and response to the domain controller, so that can be validated over there. The domain controller compares the challenge and response for authentication, and the server sends this is response at last. So brute force attacks, as mentioned in talks 2, these services provide an excellent location to test credentials discovered from other means. However, these services can also be used directly in an attempt to recover the initial set of Active Directory credentials. We could perhaps try to use these for brute force attacks if we recovered information such as valid email address during our initial red team recon. Since most Active Directory environment have account lockout policy, we won't be able to run a full brute force attack. Instead, we need to perform a password spraying attack. Instead of trying multiple different passwords, it may trigger the account lockout mechanism. We can choose and use one password and attempt to authenticate with other username that we have acquired, which is most commonly done in the red team activity. You have been provided with list of usernames discovered during the red team OSINT exercise. The OSINT exercise also indicated the organization's initial onboarding password, which seems to be change.me123. Although users should always change their initial password, we know that users often forget. So we will be using a custom script used to stage a password spraying attack against the web application that's hosted on ntlm.auth.za.tryhackme.com. So let's see if we can access the application. We can access the application since we are connected to the VPN. So we could use Hydra to assist in password spraying attack. However, it's often better to build up scripts for this type of attack, which allows us to gain more control over the process. So following is a Python code script that sprays the password. There's a password and URL. For user in self.users, response equals request.get URL, and auth equals http ntlm auth, and self.fully qualified domain name plus username comma password if response is equal to the http auth success code, and the script will print valid set of credentials found, and then it will continue. So let's try to run this script against the web application with the given set of credentials. The function takes our suggested password and URL that we are targeting as input and attempts to authenticate into the URL with username and username in the text file. By monitoring the difference in HTTP response code from the application, we can determine if the credentials is valid or not for obvious reason. Password spraying: if you are using attack box, password spraying script and username's text file is provided in /root/breaching/ad/task3 directory. We can run the script using the following command. So we need to specify the username, fully qualified domain name, password, and the attack URL. So let's copy the script. We will go to home/desktop/tryhackme if I have the directory, and we'll just create a folder called breaching AD. spray.py, and we'll just paste the script. Python spray.py. We need to specify the username. So where can we find the usernames? So okay, so we have the passwords, which is change_me123, and then we need the usernames. We can just copy this command. We can download the file from here. Okay, it's loading. Password is sprayer. I believe that contains all the required files for this attack. So let's copy the file from downloads, and then what was the file name again? It was password sprayers, and we'll just copy over here. We'll unzip the file, and we do have the anti-alarm password sprayer, the usernames. Let's see the usernames. Oh, a lot of usernames, and then we do have the default password. So we'll just use the given command. That's so we are specifying the username, the fully qualified domain name, password, and the web application URL. And then we successfully validated. We have successfully found a few credentials. We have found the 3 credentials. That's holy.powell, Heather.smith, and Gordon.stevens with the password change_me. So what's the name of challenge response authentication mechanism that uses anti-LM? I believe that's net anti-LM. What is the username of the 3rd valid credentials found by the password spraying attack? That's Gordon.steven. How many set of valid credentials were found? That's 3. What is the, sorry, okay, 4. What is the message displayed by the web application when authenticating with the valid set of credentials? So we can just check with 1 credentials, and the password was, I guess, change_me123, CHANGEME123. And after authenticating, we are getting a message, hello world. So we completed this task. So the next task that we have is LDAP bind credentials. Another method of Active Directory authentication that application uses is lightweight directory access protocol, or LDAP. LDAP is similar to anti-LM authentication. However, with LDAP, application directly verifies users' credentials. The application has set of AD credentials that we can use to query LDAP and then verify the Active Directory users' credentials. So LDAP is used by a lot of systems such as GitHub Lab, Jenkins, custom developed web applications, and printers and VPNs. So it's a popular mechanism with third-party applications. So if any of these applications or services are exposed on internet, the same type of attack are as those leveraged against anti-LM authenticated system can be used. However, and since a service using LDAP authentication requires a set of AD credentials, it opens up additional attack avenues. In essence, we can attempt to recover our AD credentials by using the service to gain authenticated access to the AD. The process of authentication through LDAP is shown below. So as always, so the user sends printing request. So this is for network connected printer that's connected in that's in the Active Directory network. So user sends printing request with AD username and password, and after that, on step 2, the printer uses the AD credentials to create a LDAP bind request, and then the domain controller provides the bind response to the network connected printer. After that, the network connected printer sends the LDAP user search to the domain controller. That the domain controller sends the user's search response, and then on step 6, the network connected printer sends back the LDAP bind request with user's credentials to the domain controller again. The domain controller at step 7 sends the server's bind response, which after that the network connected printer sends the user is authenticated and the print job is accepted. So the network connected printer authenticates the user on the last step and the print job is accepted. So if we could gain a foothold on the correct host, such as GitLab server, it might be simple as reading the configuration file to recover the Active Directory credentials. These credentials are often stored in plain text in configuration files, since the security model relies on keeping the location and storage file secure than its content. LDAP based attack, LDAP pass based attacks. However, one of the interesting attacks that can be performed against the LDAP authentication mechanism is LDAP pass back attack. So this is common attack against the network device such as printers when you have gained initial access to the internal network, such as logging a rogue device in boardroom. LDAP pass back attack can be performed when we gain access to device configuration where LDAP parameters are specified. This can be, for example, a web interface of network printer. Usually the credentials for these interface are kept default, such as admin or admin password. Here we won't be able to directly extract the LDAP credentials since the password is usually hidden. However, we can alter the LDAP configuration such as IP or hostname, and then if in an LDAP passback attack, we can just modify the IP to our IP and then send the LDAP configuration, which will force the device to connect to the attempt the LDAP authentication to our rogue device. So we'll be changing the server we can just use we can set up a responder, and we can just change the server address to our responder's address, and then we can just test the settings and we might get the LDAP credentials the anti-LM has or something like that. So we can intercept the authentication attempt to recover the LDAP credentials, performing LDAP pass attack. So there's a network printer on the network where the administration website does not even require credentials, so that's scary. So we can just visit the website. So we can't actually read the password, but we can just change the server address. So by default 10.10.10.101 is the, if we check on the 10.10. I believe it's the printer's address. So we will change so let's see what the Tryhackme had given over here. Using so Using browser inspection, we can also verify the printer's website wasn't at least secure enough to not just send the LDAP password back to the browser. So we could just try to view the source code if we can read the password field, but the password field is asterisk. We have a valid username but not the password. However, we can press test settings. We can see that authentication request is made to the domain controller, so that's the domain controller address to test the LDAP credentials. Let's exploit to get the printer connected to us instead, which will disclose the credentials. To do this, we will simply use a netcat listener. Okay, we can use a netcat listener also. So we can use netcat listener on port 389. So if we search port 389, perfect, we do have internet connection. So it's port 389 is default TCP and UDP port for LDAP. Okay, note that if you use your attack box, you need to stop the SLAPD service using this so that you can just alter the server input box on the web application to point our IP address and press test settings. So let's try to listen on this port, and then we will just we'll just copy the address, and then we'll just paste the VPN address and just click on test settings. Upon doing this, we should get the response. So you still get a connection back, but there was a slight problem. You may require more than one to try to receive connection back, but it should respond within 5 seconds. The supported capabilities tells us that we have a problem. Essentially, before the printer sends over the credentials, it's trying to negotiate the LDAP authentication and method details. It will use this negotiation to select the most secure authentication mechanism that both printer and LDAP server supports. So supported capabilities is used to response is used to it's trying to negotiate the LDAP authentication and method details so that it can use the most secure authentication method that's available on the printer and LDAP server. So if authentication method is too secure, the credentials will not if it's too secure, the credentials will not be transmitted in clear text. With some authentication method, the credentials will not be transmitted over network at all. So we can't just use normal netcat to harvest the credentials, so we have to use the rogue LDAP server. So we can try using the responder, but it wasn't mentioned. I don't know what we actually get, so I'll just turn on the responder on. So the VPN interface is, I believe it's ifconfig. So the VPN interface is the bridging 80. So we are not going to use 10.0 this time, we are just going to use bridge 80 and hit enter. And then we can just copy our IP address and just try if we can get something different. We can just click on test settings, and then we get the NTLM v1 hash for the printer. So let's see what's given in the Tryhackme. So hosting a rogue LDAP server. So there are several ways to host a rogue LDAP server, but we will be using Open LDAP for this example. If you are using AttackBox, Open LDAP has been already installed for you. So let's see if I have the, let's copy the command and see if I have the tools installed. I believe we are not being able to connect to the internet quickly because we had changed the name server on the result.conf file, but there's still other name servers that connect to the internet. So first it might be taking the Tryhackme server, and then it might be switching the servers, name servers, for whatever domains that have been used on this update. Come on. Okay, so we are configuring the admin password for LDAP directory. I believe it's installed. However, you need to configure your own LDAP rogue server on AttackBox as well. We will start by reconfiguring the LDAP server with following command. So make sure to press no when requested if you want to skip the server configuration. So for the DNS domain name, you need to provide the target domain, that's za.tryhackme.com. We need to learn more tools so that in case of engagement we can't just rely on single tool. So let's click OK. We don't need to restart the service. So click on, what do you have to do? We have to click on no, and then for the DNS domain name we need to type za.tryhackme.com, za.tryhackme.com, I guess. Yep. And then organization name, we just need to specify za.tryhackme.com, and then the admin password. We can use anything, I believe. And do you want the database to be removed when as LDAP is purged? So we need to type no. There are still files and blah 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 blah. If you enable, there are still files on /var/LDAP, which will probably break the configuration process. If you enable this configuration, the maintainer script will move the old database file out of the way before creating the new database. So it means that it will delete the old database. So perfect, we just configured the LDAP. Before using the rogue LDAP server, we need to make it vulnerable by downgrading the supported authentication mechanism. So to do this, you need to create a new LDIF file with the following content. So we can create the LDIF file on the same directory. We can just create the LDIF file, and then we just need to paste the content of this. So it's, the domain name is config, and so it's replacing the OLC SAS LSEC props with no anonymous, and then we can just copy and search what is this. Okay, so Tryhackme had mentioned the properties over here. So OLC SAS LSEC props is specified that we are using the SASL security properties, and then no anonymous means that we are disabling the mechanisms that support anonymous login, and min SSF means it specifies the minimum accepted security strength, with 0 meaning no protection. So we can use the LD file to match our LDAP server using the following command. So we can just copy this, and hit enter. We can verify that our rogue LDAP server has configuration has been applied using the following command. If you are using Kali, you may not receive any output. However, the configuration should have worked, and you can continue with the next steps. So you can just use LDAP search and see the supported mechanism. Capturing LDAP credentials. So on rogue LDAP, our rogue LDAP server has been now configured. When we click test settings at printer.za.tryhackme.com/settings.aspx, authentication will occur in clear text. If you configured our rogue LDAP server to correctly and it's downgrading the communication, you will receive the following error: the distinguished name contains invalid syntax. If you receive this error, you can use TCP dump to capture the credentials using the following command. So it has mentioned the alternative way to capture the credentials using TCP dump. It's same as Wireshark. Okay, so also note that okay, so we can just use our LDAP server so I believe we should copy this command. And then we just need to try the test settings option. .25.38 test settings. So how do I view the LDAP? So we can just view the password by trying to retest the server settings. So we have the server 10.50.25.38, and we had started the LDAP server, and we are now listening using the TCP dump on port 389. So let's click on test settings. We can try to view using -V. Click on test settings. We do have an IP address that's connected. So I believe we got the Tryhackme LDAP password. That's somewhere over here. I believe it's Tryhackme LDAP pass 1 @. So what type of attack can be performed against the LDAP authentication system? Not commonly found against Windows authentication systems. That's LDAP fastback attacks. What are the two authentication mechanisms that we can do, that we can allow on rogue LDAP server to downgrade the authentication and make it clear text? So if we cat the file, so it's no anonymous, I guess, and then let me check again. What are the two authentication mechanism do we allow on rogue LDAP server to downgrade the attack and make it clear text? So it's no anonymous and min SSFS, I believe. Let's check the hint once. Use the LDAP source to see the authentication mechanism on the LDAP server. So I believe we can check it using LDAP search dash @ LDAP : / and then we are, so that's plain and login. We had got this. We can just check it again. So it's LDAP supported mechanism, it's login and plain. So the one of them is login and the next one is plain. What is the password associated with the SVC LDAP account? I believe it's Tryhackme LDAP pass 1 @. So Tryhackme pass 1 @. Did I miss something? LDAP PASS1 PASS1 or is it dot also? So Tryhackme let's copy this and then LDAP pass 1 @. Let's try this. Your answer provided may not be in English. I believe we missed something. LDAP Tryhackme LDAP pass 1 @. LDAP pass 1. I got it. 1 @. Perfect. So we completed the task 4 authentication relay now. So we can just download the task files. Continuing with the attack that can be staged from our rogue device, we will now look at attacks against broader network authentication network protocol. In Windows network, there are significant amount of services talking with each other, allowing users to make use of services provided by the network. These services have to be used inbuilt authentication, a method to verify identity of the incoming connection. In task 2, we explored the anti-LAMP authentication used on the web application. In this task, we will be looking deeper into how the authentication works from network's perspective. However, for this task, we will be focusing on net and anti-LAMP authentication used by SMB. So SMB, this protocol allows a client like workstation to communicate with server like file share in network that uses AD. SMB governs everything from inter-network file sharing to remote administration, or even out of paper alert your computers receive when you try to print a document is work of SMB protocol. However, security of earlier version of SMB protocol was deemed insufficient. Several vulnerabilities and exploits were discovered that could be leveraged to recover credentials or even gain code execution on the device. Although some of the vulnerabilities were resolved in newer version of protocol, often organizations do not enforce the use of more recent versions since legacy systems do not support them. We will be looking at two different exploits for net anti-LM authentication with SMB. Since the anti-LM challenges can be intercepted, we can easily use offline cracking techniques to recover the password associated with the anti-LM challenge. However, this cracking process is significantly slower than cracking anti-LM hashes directly. So we had got the anti-LM hash on previous task. We can crack the anti-LM v1 hash, but we can't crack the v2. We can use a rogue device to stage a man-in-middle attack relaying the SMB authentication between the client and server, which will provide us an active authenticated session and access to this target server. So we will be discussing about LLMNR, NBTNS, and WPAD. In this task, we will look at the authentication that occurs during the use of SMB. We will be using responder to attempt to intercept net anti-LM challenge to crack it. There are usually a lot of challenges flying around on the network. Some security solutions even perform sweep of entire IP suite to recover information from the host. Sometimes due to stale DNS records, this authentication challenge can end up hitting a rogue device instead of intended host. Responder allows us to perform MITM attack by poisoning the response during the anti-LM authentication, triggering the client into talking to you instead of the actual server they wanted to connect to. On real LAN, responder will respond to attempt to poison any link, local multicast name resolution, that's LLMNR, NetBIOS, name service, NBTNS, and web proxy auto discovery WPAD request. So on large network, this protocol allows hosts to perform their own local DNS resolution for the host on the local network. Rather than overburdening a local network resource such as DNS servers, hosts first attempt to determine if the host they are trying to connect is on the same network by sending out LMNR request and see if any host responds. The NBTNS is a precursor protocol to LLMNR and WPAD requests are made to try and find a proxy for future connections. That's HTTP connections, HTTPS. Since these protocols rely on requests broadcasted on local network, our rogue device will also receive these requests. Usually these requests will simply be dropped since they were not meant for our host. However, responder will try to listen to the request and send poisoned response telling the requesting host that our IP is associated with the requested host name. By poisoning this request, responder attempts to force the client to connect to the attack box. In the same line, it starts to host several servers such as SMB, HTTP, SQL, and other to capture these requests and force authentication. So as always, you can just specify which services you can just you will be using while using responder. And let's move to next task: intercepting net anti-LM challenge. One thing to note that responder essentially tries to win race condition by poisoning the connection to ensure that you will intercept the connection. This means responder is usually limited to poisoning authentication challenges on local network. Since we are connected to the VPN on the network, we will be able to poison the authentication challenges that occurs on this VPN network. For this reason, we have simulated an authentication request that can be poisoned that runs every 30 minutes. That means that you have to wait a bit before we can intercept the net anti-LM challenges and response. Although responder will be able to intercept and poison more authentication requests when executed from a rogue device connected to the LAN of the organization, it is crucial to understand that this behavior can be destructive and thus detected. By poisoning authentication requests, normal network authentication attempts will fail, meaning users and services won't be able to connect to the host and shares they intend to. To keep this in mind that when using responder on security assessment, responder has already been installed on attack box. However, if you are not using attack box, you can install it from the GitHub repo that's given over here. and you can just start the responder with the following command. So if we were using our rogue device, we will probably run responder for quite some time, capturing several responses. Once we have couple, we can start performing offline cracking of those responses in hope of recovering the associated NTLM password. If the account have weak password configured, we have good chance of successfully cracking them and copy the NTLM v2 SSP hash to text file. We'll use password list in the downloadable file in Hashcat in attempt to crack the hash using the following command. So my bad, I told that NTLM v2. I told another story about NTLM v2 before. The password file has been provided to you in the attack box in /room/root/room/breaching/ad/tax5 directory as downloadable tax file. We will be using hashcat 5600, which corresponds to NTLM v2 SSP for hashcat. So we need to install hashcat by default if it isn't installed by default on your system. In some instance, however, we can take this a step further by trying to relay the end challenge instead of capturing it directly. This is a bit difficult to do without prior knowledge of accounts, since this attack depends upon permissions of the account we have. We need a couple of things to play in our favor. SMB signing also should either be disabled or enabled but not enforced. When we perform a relay, we make minor changes to the request, pass it along. If the SMB signing is enabled, we won't be able to force the message signature, meaning the server will reject it. The associated account needs the relevant permissions on the server to access the requested resource. Ideally, we are looking to relay the challenge and response of the account with administrative access on the server, as this would allow us to gain foothold on the host. Since we technically don't have AD foothold, some guesswork is involved in what accounts will permissions on which host. If we had already breached the AD, we could perform some initial enumeration, which is usually the case. That's why blind relay are not popular. Ideally, you will first breach AD using another method, then perform enumeration to determine the privilege associated with the account you have compromised. If you want to try this type of attack in action, just go to the Holo network, and we will also come back to this in future AD rooms. So there's a room by Tryhackme called Holo Network. You can just visit it. So let's answer the questions. What is the name of the tool that we can use to poison and capture the authentication request on network? That's responder. What is the username associated with the challenge that was captured?